Ladies and gentlemen, our introduction to nomenclature begins right now. To properly do nomenclature, we have to find the longest chain. Longest continuous chain, or if there's a ring, you do the longest ring. And we have a chain in the first one and a ring in the second. Parentheses. Parentheses are your enemy. They will confound you. You might not find the longest chain if you don't do something about your parentheses. Yeah, there's parentheses twice here. And my favorite way of getting rid of them and making this question clearer is to scribble out this subscript, which said there used to be three CH3s on the next carbon, and now I got rid of two of them, right? Still see the one. Put them back on where they belong. And you can use sticks. They don't have to be CH3s. That's a stick, CH3 when we do a stick, right? Same on the end. There's two. I got rid of one of them. Put it where it belongs. And then number the longest continuous chain. And I'll do it two ways always. There's always two ways. In this case, left to right and right to left. That's the end of the chain. Without lifting my pen off the page, I got to 2, then 3, then 4, then 5. That's the longest chain. And what's the word that describes the longest, the 5-carbon hydrocarbon? Pentane. Is that the only hydrocarbon you need to know the name of? Heck no, there's 19 more. Yes, the first 4 are tricky. Once you get to 5, it actually makes a little sense, doesn't it? Pentane 5, hexane 6, heptane 7, octane 8, nonane 9, decane 10. And then from 10 to 19 is easy too. They all end with decane, and you put an additional thing in front, like add this to 10 thing. Undecane. It's 1 plus 10 is 11. Dodecane. 2 plus 10 is 12. Can I skip to octadecane and you tell me how many are in there? Octadecane, 8 plus 10, 18. Nonadecane, 19. Nonadecane. The last one doesn't make sense. Nobody knows that an icosahedron is a 20-sided figure and that icosane is the 20th one. Well, you will know icosane is the 20th one because you have to. All right. So 5 of them are weird. Icosane, the last one, because it doesn't say 20 to me. And the first 4, methane does not say 1 to me. Does it to you? There's nothing in methane that says 1 except for maybe me. Me. There's only one me. Yeah, I got that one covered. And then E is ethane. And then there's propane for 3. And then butane for 4. And the one that seems to stick with more students than not is me peanut butter. Me is 2 letters, meth and F. Methane, ethane, peanut butter. Propane, butane. Okay. So, I don't know. The book has a personal one that works for me, but I'm the only one in the world that probably works for me. First there was me, then I met Ethel, and then we produced a baby. Who's talking here? My Uncle Cyril's talking. He was the me. All right. So that's it. You gotta learn the first 20. Can't fight it. And the end of the name is always one of those 20. Okay? And then groups. What's a group? Well, you numbered 5 carbons here, right? All the carbons that didn't get a number are groups attached to the chain. And there's 2 groups on 2, and there's another group on 4, those green sticks. And the name of the group, when it's a 1-carbon group, it's not methane anymore. It's methyl, YL. So chains end with ane. That's easy to remember, right? And groups are like sick chains. They're ill. Okay, it's not spelled. Methyl, ethyl, propyl, butyl, not propyl, butyl. There's the first four, right? What would be an 8-carbon group called? What would an 8-carbon group be called? Sorry. Not octane, but you said it. Octyl. Yes. So here we go. Now, earlier I said there's 2 ways to number a chain, and I said I was going to do it, but I didn't do it. I'm going to do the other direction in purple, and then we're going to decide which direction is the correct direction based on the people at the Union of Pure and Applied Chemistry who decided these rules that we must obey. 1, 2, 3, 4, 5. Both are pentane. To make your decision, you got to tell me where each group is numbered. Do we agree in red, the first group is on 2? So I'm writing down a 2. Do you agree in red, there's also another group on 2, sticking down? There's a group sticking up and a group sticking down. So the second group's also on 2. And hello? Why not write a 2? Thank you. And then the last group is on 4. That's this stick here. And in purple, the first group's on 2, but the second group isn't until what number? 4. That means this system isn't as good. The purple direction was incorrect. The rule is very simple. It states the direction that gives the lowest number for the first group is the correct direction. Well, we can't use the rule exactly like that because there's a tie. When there's a tie, this is the rule continued. When there's a tie, you go to the second group and compare the numbers. If one's lower, it's the correct way. If it's higher, it was the wrong way. Do not use that method, that direction, sorry. So 1, what was the name of the group when it's a 1-carbon group? Methyl. And how do you say there's 3 of them? The prefix tri, tri means 3 of them. Trimethyl, the group is called methyl, I put it in black. Each group has a number. If you have tri prefix and it's not preceded by 3 numbers, you will lose a quarter point. I will see some students try this on the test. They'll go 2, 4, trimethyl. I know where 2 of your methyls are. You didn't tell me the second one's also on 2. You need 3 numbers if there's a prefix tri. You need 4 numbers if there's a prefix tetra. You need 6 numbers if there's a prefix hexa. Okay? So it's very systematic and it's very boring. The more boring you can make it, the better you're going to do. All right? Now the next one, there's no chain, but there's a ring. And how many atoms are in the ring? There's 5. And the other carbons that it didn't get a number are groups. Now that's one direction, and the other direction that would give groups on 1 and 2 is this, and we got a slight problem now. The red direction, I didn't number the red one right at all. I don't know what happened there. Did I have a 1 here? I don't even know. I'm sorry, I just made a mess of your notes. Red has a group on 1 and a group on 2. Don't do where there's a group on 1 and a group on 5. Clearly you made a mistake. Think about it. I had that originally. You could have done better. You need the groups on low numbers, the lowest possible numbers. So with this molecule, both methods better put a group on 1 and a group on 2 because there's adjacent carbons with groups on them here, right? And the other way, I'll do on the outside, would be this. And we got a problem. Like I said, the red method puts a group on 1 and the next group on 2. The purple method puts a group on 1 and a group on 2. They're exactly the same. So the good people at UPAC said, okay, we have to invent a new rule, and they did. But Dr. Whitaker says this rule is just one rule too many. It is. I don't grade this rule. So in this case, I'm going to grade either answer for 100%. In the first one, you got 100% for that name only. That's the only name that'll get you 100%. In this one, we'll have two names. Okay. So tell me the name of the ring. It's the same as the name of a 5-carbon chain, except you throw a prefix in front. You say cyclo in front. They're very common in chemistry, trust me. So the chain is really a ring, and when you have a ring, you say cyclopentane. The group with the red number 1 is called an ethyl, isn't it? How come? The group has 2 carbons. It has a carbon here and a carbon there. And the group underneath here has 3 carbons. The first carbon's on the end of the wedge, and the second carbon's at the end of that line I drew, and then the third carbon's at the end of that line I drew. What's the name of a 3-carbon group? Propyl. So I got a group ethyl and a group propyl, and groups get listed alphabetically in front of that chain or ring. So what's first, an E or a P? E. So you tell me ethyl. There's going to be a number in front of it. And you tell me propyl with a number in front of it. And Dr. Whitaker said this is the UPAC rule that's gone too far. So he's going to accept either answer. The red system goes 1 ethyl, 2 propyl. The purple goes 2 ethyl, 1 propyl. Now the people at UPAC say the second one's better. They got their extra. Do you want to hear the extra rule just one time? I'm trying to make a fat highlighter here. Here we go. I'm going to take either one. The rule goes like this, the one you're never going to be punished for. Given a choice of 2 numbering systems that give identical numbering, you have to use the system that puts the first group that's bigger on the lower number. More massive is the actual distinction. So periodic table says this thing with 3 carbons and 3, 5, 7 hydrogens is more massive than 2 carbons and 5 hydrogens. I'm not going to grade that. I'm going to take either answer here. I will not take either answer here. There was clearly a superior way. 2 beats 4. Here, 1 doesn't beat 1, 2 doesn't beat 2. No. So, I'm sorry? Ethyl's 2 carbons. Methyl was 1 carbon. These are methyls right here, and right here. This is 2 carbons. 1, 2. There, ethyl. And please be clear, when you numbered the ring, those 5 carbons are done. You can't have a group contain any of those 5 carbons. Nomenclature, if the name doesn't tell you the number of carbons, you've made a mistake. This name says ethyl. How many carbons? 2. Propyl, how many carbons? 3 more, I'm up to 5. Pentane, how many carbons? 5. Total of 10 carbons. 5, 6, 7, 8, 9, 10. Same here. Each methyl, 1 carbon, correct? Each methyl, 1 carbon. There's 3 of them, right? That's 3 carbons. 3 plus 5 is 8, and it's definitely got 8 carbons. This is the one we combusted earlier with 8 carbons. It's the same molecule. Pulled a fast one on you. So yeah, so if you're counting a carbon both in a group and as a chain, you have definitely made a mistake. Your name will have 1 more carbon than the actual molecule does. That's not good. And that's all I have for today. And that.